Okay, so in joint variation, you can have several different variables. Some of them might vary directly, some might vary inversely. You can have a combination of different types of things. Okay, so you're going to see the word and a lot. And if it's inversely, they have to mention that it's inversely, okay, proportional to. Okay, so here comes our example. The centrifugal force C of a body moving in a circle. Okay, so it's like I'll just draw a picture up here. So it's like you're a person, here, and you're holding this string with a ball at the end and you're swinging it around. Okay, so you're swinging that ball on the string, you're swinging the string around, and this makes a circular pattern. Okay, and there's a radius r for the circle, and this ball has a certain mass, or it weighs so much. Okay, and then this creates a force as you're swinging it around, and that's called the centrifugal force. Okay, so it says the centrifugal force C of a body moving in a circle varies jointly with the radius of the circular path r and the body's mass m. Okay, and inversely with the square of the time t. Okay, so there's quite a bit going on here. So you've got C, that's the centrifugal force. It varies jointly, so put a K in there. You've got the circular path R and the body's mass M. Okay, so circular path R, body's mass M. And inversely, okay, that means that's going in the denominator, the square of the time t. Okay, so t squared. Okay, so there's my formula. I've got what? 5 variables right now. Okay, it tells us a little about the time here. The time it takes to move about one full circle. Okay, so you have let me go back to my picture. You have a ball and it's going around. How long does it take to go one time around? That's what they're talking about there. So it's how long it takes to go one full circle. Okay, as you're swinging something in the air. Okay, so there's our formula. Now they're going to give us information. A 6-gram body, that's the mass. Okay, so the mass is 6. You could make a little chart for yourself. Mass is 6. And maybe I don't want to write it there. Write it. Okay. So the mass is 6. Um, in a circle with a radius 100 centimeters. Okay, so R is 100. Okay, I wanted to double check the radius, but it's 100 centimeters. Okay, and at a rate of 1 revolution, that's one time around then. 1 revolution is one time around the circle at 2 seconds. So my time is 2. Okay, and this has a centrifugal force of 6,000 dynes. Okay, and so I looked up dyne. It's a measurement of force. Okay, so a new word for us. Okay, so we got all our variables, 4 of the 5. We don't know K, so we're going to figure out K. So here comes our equation, 6,000 equals K times, what was the radius? 100 times the mass, which was 6, over 2 squared. Okay, so I would probably do some hand math before I run to my calculator. 6,000 equals, well, I would do it this way. K 100 times 6 over 4. Then I would cancel the 4 into 100. It goes 25 times. And then I'd figure out what 25 times 6 is. Let's see. It's 300. Okay, I'm going to double check that. Just in case I'm not multiplying right. 25 times 6. Oh, I didn't multiply right. It was 150. Off in my math. These things happen. Good thing I double checked. Okay, and then I'm going to divide by 150. Okay, and so I should get a K of, those cancel. It's going to be 40. Yeah, okay. But again, I'll double check. 6,000 divided by 150. 40. Okay, so now we know K. Great. All that tells us then is K. So now we have a formula, C equals 40 times the radius times the mass divided by the time squared. Okay, now they're going to give us a situation where we have to find something. Find the centrifugal force. We're finding C, so we don't know C. 18-gram body. Okay, so that's the mass. 18. It's going to be 18. And the circle has a radius of 100 still. So still 100 for the radius. And the revolution, though, the time is 3 seconds. Okay, so time will be 3. Time will be 3. Okay, so here we go. C equals 40 times 100 times 18 divided by 3 squared. Now, the only thing on that is, I know what 3 squared is. I know that's 9. So I'd probably go 40 times 100. Probably multiply that out, but times 18 over 9. And then 9 goes into 18 two times. So if I think about it, 2 times 40 is what, 80? And 80 times 100. So I'm going to say C is 8,000 dynes. And then I can also check that. All right, with a calculator, I can check that.